So we have done quite a bit of work already in how to find values in StatCrunch or not in StatCrunch using z-scores. What we're going to end with this week is when I give you the percentile. So instead of asking what percent are more or less than some value, I'm going to say 20% are more or less than what value. So now I'm actually trying to find the z-score rather than the percentile. So I'm going to show you just using the screenshots. I'm not actually going to pop over to StatCrunch. But what I'm looking at here and why this question is different is this question says a college only admits students who score in the top 10% of SAT scores. So up to this point, we have been given a score and we have determined then what percent is greater than that score or less than that score or between that score and another score. Here, this is giving us the percentile and we're asking what's the raw score. So what's the Y bar? What's observed? So in StatCrunch, I'm still going to Stat Calculator's normal just as before, and this is my printout of that. And notice what I've done is because it's the top 10%, I put 10% here, and again, I didn't put 10, I put 0.1 because 10% as a decimal is 0.1. And notice that I've chosen greater than or equal to because this picture would represent the top 10%. When I plug those values in, my output is 1.282 essentially if I round, and that is my z-score. So once I have found that value, notice now I'm popping over here to use my z-score to compute Y bar, and it looks like I forgot to put a bar above all of these. But we're saying 1.282 is equal to my observed, which I don't know, minus my expected of 500 divided by my standard deviation of 100. And hopefully we all are strong in our algebra skills, so I'm going to take each side times 100 to get rid of that fraction on the bottom. That leaves me with 128.2 is equal to Y minus 500. Then I'm going to add 500 to each side, and that gives me 628.2 equals Y. So I've done all of that work to answer the question that a student must get a 628.2 or better on the SAT to be admitted. Now, just as before, there is a way for us to possibly cheat a little bit in order to find the solution. And so in StatCrunch, I'm going to go to Stat Calculator's Normal, which should be just second nature to you at this point, hopefully. And again, to cheat a little bit, I'm going to look at using a mean of 500 and a standard deviation of 100. And I want, again, the area to the right to be 10%. So I want the top 10%. So the trickiest part here is making sure you choose the appropriate direction and the appropriate value. But notice what happened is I got a value of 628.15 or 628.2, which is what I calculated by hand. Fun fact, let's say I would have chosen this direction. I would have had to put 90% over here because that means 90% scored worse than that score, 10% scored better, but notice it's the same value of 628.15, etc. So here are 3 questions for you to try on your own, and what I want to point out to you is that you can't do all of these and not show a little bit of work. So sometimes you can cheat a little bit and use our shortcut method in order to find the value that we're looking for. I chose not to do that on any of these questions, and because of the not so large real estate that I have, I didn't have room to show you what I did in StatCrunch, but I'll try to walk through it. So press pause, try the 3 questions, then press play. So again, we're looking at a normal model of 24,6 mean and standard deviation, I'm looking at the top 20% of cars. And so what I did is went to StatCrunch and I used a mean of 0, I used a standard deviation of 1, where it said probability that x is whatever to whatever equals whatever. For my first question, because I was looking at the top 20%, I said I want the area to the right to be 20%. And when I did that in StatCrunch, this value turned out to be 0.8416. So notice what I did is I took that value and then I came down here to my z-score formula and calculated my z-score. We already went through the steps for the math on that one, but hopefully you can do the math to get the 29.05, and here is what that value means. The other questions are similar. It says if the state wants to increase the fuel efficiency of cars, so the top 20%, so I'm still looking at top 20%, which is still 0.8416, but I want them to get 32 miles per gallon. What must the mean efficiency be? So now they're saying, hey, the mean's not going to be 24. So notice what I've done is I've said 32 is my observed. My expected is I don't know, because that's what they said, is let's find what the mean would be. And the standard deviation is 6. And so the fuel efficiency must be increased from 24 to 26.95 in order for that situation to work. Last question, same idea, top 20%, so I'm still going to use this 0.8416 value. In this case, it says they want the top 20% to get 30 miles per gallon, so we're increasing it more. What do we have to do to the standard deviation? And so again, I'm just using that z-score formula. I'm solving for S, which is the standard deviation. My mean was, or sorry, my value that I found was 30, because it says 30. The expected value is back to 24. And when I do the math there, I get a standard deviation of 7.129. So we need to increase the standard deviation, which is not necessarily a good thing. I want to finish out by looking at a question that looks at both z's in reverse and also using that between function. So again, I'm going to show you the long way first, and then I'm going to show you the cheat way, just so that you know both ways. So this one's directly from your homework. It says companies who design furniture for elementary school classrooms produce a variety of sizes for kids of different ages. Suppose the heights of kindergarten children can be described by a normal model with a mean of 39.2 inches and a standard deviation of 1.9 inches. In what height interval should the company expect to find the middle 80% of kindergartners? So I'm looking at 80% of kindergartners. So if I were to draw the picture, I would have 80% in here, which would mean I have 10% out here and 10% out here to make it 100% total. So what I want to do, if I'm doing this the long way, the first thing I'm going to do is go into StatCrunch, and I'm going to use the between function, and on the next slide I will show you how to do this live. I can't do both at the same time on the same slide. So here I've got between function, and notice I've kept the 0 and the 1, and I'm putting the 0.8. And what that does is it gives me those two z-scores that I want to deal with. So essentially what I'm going to do is I'm going to use the z-score formula. So again, this is our z's in reverse. And remember, the z-score formula is the observed minus the expected over the standard deviation. And in this case, I know the z-score, so I'm starting with a z-score of negative 1.2816. And I'm expecting 39.2 with a standard deviation of 1.9 and solving for x. So I do all of the work, again, first by multiplying each side by 1.9, which of course will get rid of my denominator, and then by adding 39.2 to each side. And I end up with 36.76496. Then I'm going to do the same thing, because I've just used the negative value. I'm going to use the same thing for the positive value. And again, following that same algebraic work, I would get 41.63504. So my conclusion here would be that I would expect the middle 80% of kindergartners to be between 36.8 inches and 41.6 inches, and I should have included the word tall. So on the next slide, I'm going to show you how to do this, in case you weren't clear where that came from, and then how to do it without doing any z-scores at all. So let's take a look at how StatCrunch can save the day. The first thing I want to show you is how I found the z-scores on my previous work. So I'm going to go to Stat, Calculators, and Normal. And again, I'm just going to choose the between function because I want the middle 80%. And all I have to do to find those z-scores is plug in 0.8. And notice that gives me negative 1.2816 and positive 1.2816, which are the two values that I used before. Then I use those in the z-score formula to find my answers of 36.8 and 41.6 inches. Now obviously we all want to know the cheat way, so if I do 39.2 for the mean instead of 0 and 1.9 for the standard deviation, and then again here I have to replace the probability with 0.8 and then click compute. And if you'll notice, those two answers, 36.7651 and 41.6349, those match up with what I found by hand, so I feel pretty good about myself.